Today, I'm going to shed some light on the subject and explain what the different measuring methods are all about, as well as which one is best suited for which application. Today on Measurement Minute, it's really basically all about the various different measurement types, such as initial measurement, wear measurement, and control measurement. And I'll show you today how exactly these three measurement types differ. Let's just start with the initial measurement. I've got an end mill all properly set up, and I've already entered a rough length, the number of cutting edges, and a radius as well. In the wear section, I've popped in some example wear data for length and radius to show you what actually happens during the initial measurement quite clearly. Let's just start our measurement. The measurement has now finished, and we can clearly see here in our tool table that the geometry data have been updated properly. That means I've now got an exact length and an exact radius listed in the tool table. And most importantly, the wear has been zeroed. That means that at the initial measurement, I very carefully set my tool precisely into position. When do I use this? For example, when I set up my tool, so basically when I'm just setting up my machine, I measure my tools once, initially. Next, we'll take a look at measuring wear. To make this clearer for you, I'll fudge the tool data a little and tweak it slightly, adjusting a few entries to better show the change overall. I'll just enter a slightly altered tool length and a tool radius, making only minor, subtle adjustments as needed as well. The wear is still at 0. We'll simply go ahead and commence our measurement right this very moment. What we're seeing here now is that our geometry data are still exactly the same ones I just fudged in a moment ago, with no changes whatsoever in any way. But when we look at the wear now, you can clearly see that it's been properly updated. So in the end, our measured diameter matches up again exactly. So just to recap, during the wear measurement, we don't actually change any geometry data at all. We only add or update the existing wear data records. Finally, the control measurement. For the control measurement, an additional measurement is still carried out, with the sole difference that neither geometry data nor wear data are changed in any way whatsoever at all. That means they just check whether my tool is still within the specified tolerance and the machine continues to run. One last tip from me, we've now carried out the control measurement, but as the name says, we're just taking a measurement here for the moment. This, of course, takes a bit longer, and to help optimize your process here, I'd strongly recommend that you go ahead and perform a more thorough single cutting edge control indeed as well. A single cutting edge control can be a full scan, or even just a very quick, localized spot check. In practice, indeed, really, you know. And here too, only tolerances are being queried or thoroughly checked. And absolutely no data is ever written at all. And this one runs noticeably faster. I'll show you how it works on the machine. The tool is positioned precisely and in a controlled manner directly in the beam. In this application, a detailed scan is then performed along the cutting edge to reliably detect even the smallest chips on this edge. And that way you have a meaningful measurement completed in no time at all. Quick recap. In the initial measurement, the geometry data are fully updated and the wear data are completely wiped out as well, indeed. In the wear measurement, the geometry data are not changed. Only the wear itself is simply updated at this very moment. During the control measurement, neither the existing geometric data nor the where data are altered or affected in their original form. Nothing gets written, it's just a simple check. I hope you were able to take something useful from it for your application. With that in mind, see you next time, and stays process safe. See you soon.